Absolutely electric. The moment you enter a modern welding hall filled with robotic arms, you know serious work is about to begin. This is where the Yasawa Robots on Board welding system shines, combining the compact RWV2 positioner, a Motoman MA1440 robot, and the DX200 controller for seamless, automated arc welding. The process kicks off as the operator loads metal parts onto the RWV2 positioner. This smart fixture rotates and tilts the workpieces, allowing the robot to access every angle with ease. Once secured, the MA1440 robot springs to life. Guided by pre-programmed instructions, it maneuvers its welding torch along the joints, maintaining steady speed and distance for each weld. The DX200 controller acts as the brain, synchronizing every movement and monitoring process parameters, current, voltage, and torch travel, down to the finest detail. Sparks fly as the arc ignites, fusing metal with remarkable consistency. Throughout the cycle, the system's sensors adjust in real time to keep the welds precise and repeatable. Watching this robotic choreography in action is truly impressive. Every finished part reflects the blend of engineering skill and high-tech automation driving today's manufacturing. Steel production at RIMJHIM Ispat is an incredible display of scale and precision. In massive plants at Unnao and Hamirpur, scrap is transformed into stainless steel using cutting-edge machinery and a workforce of 4,000. Each year, over 350,000 tons of wire rods, slabs, blooms, coils, and bright bars are manufactured to the highest standards. Technicians conduct rigorous quality tests around the clock, ensuring only the finest steel leaves the facility. It's impressive to see such a blend of heavy industry and thorough control in action. Every product reflects the skill, technology, and commitment that have made this company a trusted name in global steel markets. The first time you watch an H-beam welding line in action, it's hard not to be drawn in by the sheer scale and coordination of the process. Massive steel plates, each one carefully prepared and measured, are hoisted onto the entry conveyor. These raw plates are the starting point for building robust H-beams used in everything from skyscrapers to heavy machinery foundations. The journey begins as the plates are precisely aligned on the assembly station, where high-strength tack welds fix the flanges and web in their initial positions. The assembly clamps can handle plates over 25 millimeters thick, ensuring stability during setup. It's impressive to see the automated manipulators position these heavy elements so swiftly and accurately. This automation reduces manual labor and speeds up cycle times remarkably. Once aligned, the partially assembled H-beam moves along the powered roller conveyors to the main welding station. Here, twin welding heads spring to life, moving along both sides of the beam. Each head can deliver up to 1,000 amps of current for deep penetration, guaranteeing structural integrity. Using advanced arc welding technology, they lay down deep, uniform welds that fuse the flanges to the web. Real-time laser tracking systems monitor the position of the torch, helping maintain flawless bead placement. Real-time sensors monitor the weld pool, current, and voltage, making adjustments on the fly to guarantee penetration and consistency throughout the entire length of the beam. The scale of these welds is something you have to see to believe. Standing next to this operation, you can feel the intensity of the process. Every spark and every pulse of the arc reflects the precision at work. This station can process beams up to 18 meters long in a single pass. Each finished H-beam is then subjected to rigorous inspection, with technicians checking for weld integrity and dimensional accuracy. The final products are stacked and readied for delivery, destined for construction sites and heavy industry projects. This level of automation, control, and technical know-how is what defines modern heavy steel fabrication. The roar of a forging press line is unmistakable, and when the EUM UCO system comes alive, it's clear you're witnessing heavy industry at its best. Everything begins with an automated magazine, loading hefty steel bars onto the line, setting the stage for large-scale transformation. Next, the bars enter a 1,450 kilowatts BBS Brown Bovary induction heating installation, ramping up the temperature with a 500 Hz frequency to prepare the metal for forging. It's impressive to see how quickly these bars reach the ideal forging temperature, glowing red-hot and ready for action. A powerful FICEP hydraulic press slices the heated bars into billets, up to 130 millimeters in diameter. The precision of each cut is crucial. The entire downstream process depends on billets with consistent size and heat. Workers monitor the process closely, knowing there's no room for error at this stage. Then comes the heart of the operation, the EUMUCO hydraulic press for forging shell casings weighing up to 50 kilograms. This press features two main units. The first, a compression and push broaching section, brings a staggering 630 tons of force and a drop hammer traverse of 1,250 millimeters. The second, a drawing unit with calibrated rolls and rings, shapes and finishes each shell casing with a 200-ton force and a massive 3,200 millimeters drop hammer traverse. The sound of the press in motion is unforgettable. Metal moves and reshapes with every thunderous strike. Hot casings are then moved by a robotic stacker, which neatly arrays them on pallets for normalization. It's an efficient, highly automated process. There's something fascinating about seeing glowing steel shells handled so seamlessly by robotic arms. The line doesn't stop at forging. Next, a GF programmable hydrocopying lathe turns each casing with high efficiency, followed by the final 130-to-1 programmable lathe, which performs final precision turning on the inner surfaces. Every casing must pass these steps to guarantee dimensional accuracy and flawless performance. For bending shell casings, the Automated Technological Module ATM takes over. Billets are charged into the system, heated by a 375 kilowatts EMA electromachine and induction unit running at 1,000 Hz. A vibrating forging press aided by two manipulators expertly bends each shell, ensuring every part meets strict tolerances. Watching this line operate, you can't help but admire the choreography of machines and the raw energy required to create such heavy-duty components. Every step reflects the experience, technology, and teamwork behind modern forging. Witness the awe-inspiring process as engineers lay Google's ultra-fast submarine cable beneath the Pacific. Each segment is carefully lowered from the ship, connecting continents and promising data speeds up to 60 terabits per second. Watching a 5.25-inch thick steel plate become an ASME-certified cylinder is a masterclass in heavy fabrication. The process starts with precise plasma cutting, slicing each section from massive stock. Next, the plate is fed into a huge rolling machine, where hydraulic rams gradually bend the steel into a seamless cylinder. Each step requires careful alignment to prevent warping. Welders work skillfully by hand, fusing the seam with multiple passes to meet the demanding ASME codes. Their steady hands and years of experience are crucial for consistent, high-strength welds. As each weld solidifies, the team monitors the process closely, adjusting technique as needed for perfect penetration and uniformity. Finally, the finished cylinder is moved for further processing, ready to take on demanding pressure vessel duties. The transformation from raw plate to certified cylinder is a testament to both craftsmanship and steel. It's always exciting to see cutting-edge technology in motion, and today's showcase of dynamic milling using EdgeCam waveform on the YCM NXV1020 is no exception. The YCM NXV1020 roars to life. Its 12,000 revolutions per minute spindle and high-torque servos working in perfect sync. Flood coolant splashes over the part, and the end mill begins its dynamic waveform toolpath, slicing effortlessly through the billet. Trochoidal motion keeps the cutting load constant, so chips curl away cool and bright, even at high speeds. There's a kind of tension. As the tool arcs through each pass, corners are tackled without hesitation, and the pace never lets up. Every motion is tightly controlled. Servo motors respond instantly to adjustments, and the entire operation runs under the close eye of sensors monitoring spindle load, temperature, and vibration. It's fascinating how the system automatically tweaks feed rates and speeds in real time to prevent tool wear and surface flaws. Watching the machine execute tight pockets and deep contours with such precision is a real thrill, especially knowing tolerances are sometimes as tight as plus or minus 0.01 millimeters. The machinist monitors the run with sharp focus, checking chips for color and shape, listening for the subtle signs of chatter or overload. Inspection gauges come out regularly between passes to confirm dimensions. When needed, a quick adjustment is made, and the machine is back to perfect form. Burrs are minimal, thanks to constant chip evacuation and optimized engagement. The finished surface shines, almost mirror-like without secondary finishing. A powerful stream of compressed air is directed right at the cutting edge. This air blast clears chips away instantly, keeps the cutting zone visible, and helps dissipate heat, maintaining tool life and surface integrity. The dry cutting area also makes it easier to inspect the part during machining. It's impressive to realize that the smoothness of this operation owes much to careful cam programming. Before this moment, a skilled programmer used EdgeCam to design every detail of the waveform toolpath. Simulation allowed fine-tuning of entry, ramping, and all critical parameters, ensuring tool engagement remains steady and heat is kept under control. Even small tweaks to feeds and stepovers made a massive difference, and the entire path was tested virtually before a single chip was made. Once programming was set, code was sent directly to the YCM's controller. The machinist clamped the billet, touched off 0 points with a probe, and checked alignment down to microns. Every surface was cleaned, and all clamps double-checked, since even the smallest vibration could ruin such a high-speed process. As the last pass ends, the part emerges flawless, razor-sharp edges, uniform finish, and all critical dimensions spot on. Measuring on the CMM confirms every tolerance is met. It's an amazing feeling, seeing software and machinery come together so seamlessly. This is what happens when technology and skill truly align. Steel transformed, limits pushed, and a new standard set for modern manufacturing. Few things are as impressive as the machining of massive diesel engine components. In the Wärtsilä facility, precision tools carve enormous engine blocks on a Waldrich-Coburg machine, creating surfaces with tight tolerances. Each pass is controlled, monitored, and fine-tuned for flawless geometry. The sheer size and accuracy involved in this process make you appreciate the scale of engineering required for modern power generation. Certified reconstruction of a Caterpillar D8T tractor is nothing short of an engineering marathon. The process begins in Ferreros' workshop, where every component is carefully disassembled, cleaned, and inspected. Specialists evaluate parts for wear or damage, replacing anything that doesn't meet strict standards. The engine, transmission, and hydraulics are all restored or rebuilt using genuine Caterpillar parts, ensuring peak performance. Reassembly is a thorough operation, with technicians following factory procedures down to the smallest bolt. Key systems are calibrated and tested under load, simulating real working conditions. It's impressive to see such attention to detail at every stage, especially when major assemblies come back together as smoothly as new. Every component receives a fresh coat of classic cat yellow, making the finished tractor instantly recognizable and giving it that bold, like-new presence on the shop floor. Watching a machine given a second life is a testament to the value of skill, dedication, and engineering expertise in heavy equipment service. Step inside a modern facility where advanced engineering and practical reliability work side by side. The production line at Servi Group brings hydraulic cylinders and valves to life for some of the world's most demanding industries. The journey begins with nodular cast iron and high-performance alloys, carefully selected for each specific project. Massive CNC machining centers integrated into a flexible manufacturing system shape and bore raw materials into precise components, with over 1,000 tools on hand to tackle complex cavities and custom geometries. Throughout the process, parts are continually measured using advanced laser systems, ensuring tolerances as tight as 1/100th of a millimeter. Machined components move through a rigorous cleaning and deburring sequence. Chips and shavings are removed, sometimes with thermal deburring, where a controlled gas explosion instantly vaporizes all remaining debris. It's an intense step, but absolutely crucial for reliability. Surface treatment is handled in-house, creating corrosion-resistant finishes even before any oil touches the product. Every valve and manifold is function and pressure tested, meeting strict offshore and industry standards. For large cylinders, certified operators perform submerged arc welding, using automated tracking and specially designed joints for maximum strength. Final assemblies are pressure tested, function checked, and inspected with particle counters and precision gauges. Each completed product stands as a testament to precision engineering and technical expertise. Seeing these cylinders and valves ready to ship, built to operate under extreme conditions, you appreciate how world-class manufacturing sets the foundation for power and motion control across the globe. Ours. A raw gear coupling hub is transformed with remarkable precision on the Fowler CNC gear hobbing machine. The process starts as the blank hub is clamped securely, ready for cutting. Guided by a sophisticated CNC program, the hob cutter rotates into action, carving each tooth with exact alignment and consistent depth. Every motion is synchronized, so the resulting tooth geometry meets demanding specifications for strength and smooth operation. It's genuinely impressive to watch the gleaming teeth take shape, chip by chip. As the cutter advances with unwavering control, the finished gear coupling hub emerges with a flawless pattern, reflecting both modern automation and skilled oversight. This process shows just how vital precision machining is in creating components that keep heavy machinery running at peak performance, cycle after cycle. The making of an industrial steel vessel head begins with shear scale. Imagine a steel disc over 3 meters across and 35 millimeters thick, set onto a manipulator with absolute care. As the dishing machine engages, massive force slowly presses the disc into a deep, hemispherical form. Watching the metal yield step by step is truly impressive. After forming, the vessel head moves to the flanging station, where the rim is skillfully curled and leveled for a perfect fit. Technicians monitor every stage, adjusting parameters to ensure precision and strength. Each completed head is carefully lifted from the line, its flawless surface reflecting the expertise behind every step. The entire process is a powerful reminder of how far industrial forming has come.